Watch the complete playlist on the app Pions. Download the app now.
2-point charges plus 6q and minus 8q are placed at the vertices of B and C of an equilateral triangle. So this is an equilateral triangle ABC with side A as shown in the figure. Okay, so very simple. There is a 6 coulomb q charge, and here minus 8q. And the side length of this equilateral triangle is A. Obtain the expression for the magnitude and the direction of resultant field. Now this is very, very important thing. 4 things which you have to be very careful while reading the question. Force, field, potential and potential energy. All 4 things are different. And since they are different, okay, their formulas look quite similar. Okay, so you have to be very careful with that. So direction of resultant electric field at vertex A due to these charges. Direction also and magnitude also. So let's proceed in a similar fashion. We have a positive charge here as per the question at B. If there is a positive charge, okay, what is this length? A. This length A, because it's an equilateral triangle. So if it is a positive charge at point A, the field will be radially inward or outward? It will be outward, because for a positive charge, it will be away from the charge. Along this direction, this will be electric field at A due to B. Correct? Sir, why you have drawn it at this direction? Why can't you draw it like this or there? Why? Because what is the condition to draw the direction? It should be along the line joining the point at which you are finding and the charge where it is placed. That line, along that line you have to draw. Clear? Sir, what if this charge was placed here and they are asking at point A? Will it be still in the same direction? No. Then you will imaginary line like this. This side it will be. Okay, along the line joining the charge and the point. Great. Electric field at A due to C will be radially outward or inward? Sir, it will be inward towards the negative charge. Radially inward towards the negative charge. So it will be EAC. Electric field at A, okay, due to C towards the charge. Why towards the charge? Negative charge. Clear? Okay, great. So one is vector in that direction, another vector is in this direction. What is the angle between them? So we know equilateral triangle, each angle is 60 degrees. So if this is 60, this becomes a linear pair and 180 minus 60, which is 120 degree. This is the angle between the EAB and EAC. Okay, great. So if EAB and EAC has this angle, how will you find the resultant? We will see within a minute. Let's first find the magnitude of individual electric fields. So electric field EAB, that will be equals to, I'm just writing it as K. You can write 1 by 4 pi epsilon naught. I'm writing it K to make the calculations simple. So this will be K. Charge is 6Q upon separation is A square. I hope this is clear. Separation of AB. Okay. So you can write it as KQ by AB square. AB is nothing but A. This is our electric field EAB. Let's write electric field at point A due to C. That will be again K 8Q upon separation A square. If you are still confused, sir, why you have not taken the negative sign here? Listen very carefully. Since it is negative, the direction of arrow is downward. Clear? If it was positive, this EAC was supposed to be in the opposite direction away here. So you have already considered the negative sign in this arrow. You can't do it twice. Let me repeat again. Since here at point C, the charge is negative. And since it is negative, the arrow of EAC is towards the negative charge. If it was positive, it was supposed to be away. So these arrows are already considering the signs. So you will not repeat the sign again. So that's why EAC, we have not taken here negative sign. So you have to avoid signs in which cases? Fields and forces. Be very careful with that. Done with that? Great. Now what we will do? We will simply directly add them? No. You can't add any two vectors like that. Let me remind you a relation from 11th standard. If you are given with any two vectors, R will be equals to A square plus B square plus 2AB cos of angle theta, where A and B are the two vectors which you are adding. Theta is the angle between them. So what is here theta in our problem? Theta we got 120 degrees. Sir, which angle we have to consider? The angle between the two vectors. The angle between the two vectors we have to take. That is our 120 degree. Now this will be equals to root under A. What is A? A is K into 6Q upon A square whole square, first vector, plus B vector, which is K 8Q upon A square whole square, A square plus B square plus 2 times A. A is what? K into 6Q upon A square into B, K into 8Q upon A square cos of 120. I hope now you should know that why I have taken that 1 by 4 pi epsilon naught K. You can take it as 1 by 4 pi epsilon naught, but it will look more complicated for you. So to avoid that, I just took it as K. Now what is cos 20? Bio people, be very careful. You have to remember these values. Cos 120 minus half. Let's substitute here. So cos 120, I am putting here minus half. And when you put minus half, this 2 will cancel out with this 2 and the minus 1 will take place over here, this plus. So let's see what we are getting here. Be very careful with the calculations. So this will be over here root under k square 36 q square a to the power 4. K square 64 q square a to the power 4. Minus, be very careful from where I got minus, this minus half. 2 cancels minus. K into k, sir, k square. 6 into 8, 48. Q into q, q square a to the power 4. All the three terms have something common in them. Sir, what is common in them? Let's write that. K square is there in all the three terms. Q square is there in all the three terms. E to the power 4 is there in all of them. So what we left with is the first term 36. Second one 64. Third one 48. Clear it is? Let me repeat. In case if you have not understood how to take common, simply multiply this outside bracket inside this. So 36 into k square q square by e to the power 4, 64 into this thing and minus 48. 36 and 64, 6, 4, 10, 1, 6, 4, 10, 100. 100 minus 48 we left with. So this will give us the resultant electric field at point A will be equals to, be very careful, what can you take this k square q square and a to the power 4 out of root? Yes. You will be left with 1k, 1q because root and square will cancel, and a to the power 4 you left with a square. Root under 100, 36 plus 64, 100 minus 48. And 100 minus 48 is how much? Let's see. So this will give us net electric field at A will be K Q upon A square. 10 minus 8 is 2 and 9 minus 4, 552. So root 52 kq square by a square. That's your final answer for this question.